Hi, fifth graders. I'm glad you all are back for another math lesson today. For today's lesson, all you will need is some form of a dry erase board and a dry erase marker. If you don't have that, a pencil and paper will work just fine. Are you all ready to get started? Me too. Okay, so let's get started. You'll see today that we are again working on decimal word problems. Looking at our learning target, it says that I can solve and create single and multi-step problems involving addition, subtraction, and multiplication of decimals using a tape diagram and the standard algorithm. Now, there's a lot of vocabulary words in this learning target. Let's pull out some of those. The first one I see is decimals. So we're again today going to be working with decimal numbers. The next one I see is tape diagram. Now, some of you may be familiar with a tape diagram and some of you may not. If you're not, that's okay, because that's what we're practicing with today. But a tape diagram is a simple bar drawing that you can use to represent your thinking while solving a word problem. And finally, I see the key word standard algorithm. What does standard algorithm mean? Well, you've been practicing solving addition, subtraction, and multiplication problems of decimals using concrete materials like place value discs or base 10 blocks. You've also practiced that by using pictorial models. Today, we're going to solve addition, subtraction, and multiplication of decimal problems by simply using the numbers. All right, let's go ahead and get started with our first problem. It reads, the snowfall in year 1 was 2 3/100 meters. The snowfall in year 2 was 1 6/10 meters. How many meters of snow fell in years 1 and 2? So the first thing I know is that in year 1, 2 3/100 meters of snow fell. In year 2, I know that it was 1 6/10 meters. So I'm going to go ahead and make my tape diagram now. And I want you to do the same on your paper or dry erase board. Now, there isn't one single correct way to make a tape diagram. My tape diagram may look different from your tape diagram, and that's okay. As long as we're both getting the correct answer and we can both use our tape diagram to explain our thinking, we're good. So, the first thing I want you to do is on your paper, I want you to put Y1. That Y1 is going to represent year 1, and then I want you to make a bar. After you do that, I want you to make Y2. What do you think Y2 represents? If you said year 2, you're absolutely correct. Y2 represents year 2, and I want you to make a bar that represents the same space as year 1. So the two bars should be exactly the same length to start. Now, some of you may be saying, but year 1 and year 2 shouldn't be the same length because they don't represent the same number. And you're right. Year 1 represents 2 3/100. And I know that 2 3/100 is greater than 1 6/10. So on my year 1 bar, I'm going to add on to it. And I want you to do the same. On your year 1 bar, go ahead and add on to that first bar because we know that 2 3/100 is greater than 1 6/10. Now I can go ahead and label my bar. That first bar we can put as 2 3/100. Then for your second bar, go ahead and label that as 1 6/10. Now we're not done with the problem yet. Now we want to figure out how much snow fell in both years 1 and year 2. What operation do you think we're going to use to solve this word problem? Did you say addition? If you did, you're absolutely correct. We're going to have to add 2 3/100 and 1 6/10 together. So on your paper, let's go ahead and set that problem up using the standard algorithm. Now, you'll see on here that the decimal numbers are lined up. And when adding or subtracting decimals, you may have heard your teacher say before to make sure your decimal numbers are lined up. But why does your teacher tell you that? It's important to keep your numbers lined up because if I move a number to a different place, it could change the value of that number significantly. For example, if I wrote this problem as 2.3, which is 2 3/10, that's a totally different number than 2 3/100. Think back to when you were using your place value disk and you put your disk in the correct place. You have to do the same thing when working with your numbers. So I made sure that my numbers are lined up so I can go ahead and add in this particular problem. Now, when looking at this number 2 3/100 plus 1 6/10, I noticed that there's not anything right here. If that space is blank, what does that mean is there? Did you say 0? If you did, you're right. So I'm going to add in a 0 there because I know if that's blank, then really that means that there's a 0 there. And I know that 6/10 is the same as 60/100. So I have my problem now and I'm ready to add. Let's go ahead and start. Okay. So starting in my hundredths place, I know that 3/100 plus 0/100 is equal to 3/100. Moving on to the tenths place, I know that 0/10 plus 6/10 is equal to 6/10. I'm going to remember to bring my decimal down. And then finally, moving on to the ones column, I know that 2 1s plus 1 1 is equal to, you've got it, 3 1s. So now I found my answer to this problem. Because I was working an addition problem, I can say that I found the sum. And the sum is 3 and 63/100. Now, I like to put my final answer in a sentence so it can help me make sense of the problem. So in this case, I can say that 3 and 63/100 total meters of snow fell in years 1 and 2. Taking a look now at problem 2. It reads, Max, Maria, and Armin were a team in a relay race. Max ran his part in 17 3/10 seconds. Maria was 7/10 slower than Max. Armin was 1 5/10 seconds slower than Maria. What was the total time for the team? So one of the first things that I know is that Max ran his part in 17 3/10 seconds. Maria was 7/10 slower. And then Armin was 1 5/10 seconds slower than Maria. And I'm trying to find the total time for the team. So for this, because we have 3 people in this problem, I want you to go ahead now and make 3 tape diagrams. You're going to label each of them for your different people. So you're going to have a bar for Max, a bar for Maria, and a bar for Armin. You can make them all the same length to start. Go ahead and pause the video now if you need some time to do that. All right, now that you have your 3 tape diagrams drawn and they're all the same length, we need to make some adjustments because we know that they all didn't finish the race or the relay at the same time. We can start off by labeling Max's bar because we know that Max finished in 17 3/10 seconds. So I'm going to go ahead and on your paper, go ahead and label the first bar for Max as 17 3/10. Next, we have Maria. We know that Maria was 7/10 slower than Max. That means that Max finished at 17 3/10, and then Maria finished 7/10 seconds later. So we need to add a little more to Maria's bar because it took Maria a little bit longer to finish. So we're gonna add a little bit more to her bar, and then we can label that part that we added. That additional part that we added represents 7/10 because that's how much slower Maria was. Not very much. Then next we have Armin. Now Armin was almost the same as Maria, except Armin finished 1 5/10 seconds slower than Maria. So we have Maria's bar label now. I'm going to do the same thing for Armin as Maria because he was almost the same as Maria, but then I need to do something else to Armin's bar. Any ideas? If you say I needed to add a little bit more on, you're right. I need to add some more on to Armin's bar because he finished 1 5/10 slower than Maria. So I'm going to add some onto his bar. And then I'm going to label that additional part that I added as 1 5/10. All right, I'm not done with the problem yet because we're still trying to figure out what was the total time for the team. So I need to now figure out how much did all three of them score combined. What operation do you think I would need to use for this problem? Did you say addition? If you did, you're right. I need to add these 3 times together. The first thing I know is that Max was 7 3/10. There's nothing I need to add there. So I'm going to go ahead and add in 17 3/10 right there to represent Max. Now I need to figure out how long it took for Maria to run the race. To do that, I need to add 17 3/10 plus 0 7/10. And remember, we're using the standard method today. So I'm going to write down my problem, and you can write down yours. Starting in my tens place, I know that 3/10 plus 7/10 is 10/10. I can rename 10/10 as 1 whole, or 1. So to do that, I'm going to put a 0 in my tens place, and I'm going to move that 10/10, or 1 whole, over to the ones column. Now I can say that 7 ones plus 1 1 is 8 ones. Now I have 110 plus 0, and that's still going to be 110. So I can bring that down. So I'm left with 110 and 8 ones, which is the same thing as 18. So now I've determined that Maria took 18 seconds to finish her part of the race. Now, we still have to figure out Armin's time. To figure out Armin's time, we know that he's almost the same as Maria. In fact, the only difference between Maria and Armin is that Armin took 1 5/10 more time to finish than Maria did. So I now know that I need to add 1 5/10 to 18 to figure out what Armin's time was. To do that, I'm going to add again. I know that 0/10 plus 5/10 would give me 5/10. I know that 8 ones plus 1 1 is equal to 9 ones. And again, my 110 I can bring down. So now we've determined that Armin finished the race in 19 5/10 of a second. But we're still not done, because now we need to determine what was the total time for all 3 of them to finish. What operation am I going to have to use to solve how long it took all 3 of them to finish? If you said addition again, you're correct. I'm going to first start off by adding Max's score and Maria's score. So that's 17 3/10 plus 18. To do that, I know that 3/10 plus 0/10 equals 3/10. I know that 7 ones plus 8 ones equals 15 ones. Now I can rename 15 ones as 110 and 5 ones. That 5 I can leave in the ones place, but that extra 10 I'm going to move over into my tens column. That's why we put a 1 on top. Now I need to add 110 plus 110 plus 110, which would give me 3 tens. So I have a total now of 3 tens, 5 ones, and 3 tenths, which is read as 35 and 3 tenths. I know that's the total between Max and Maria, but I still need to add Armin's time onto that. So I now need to add 35 and 3 tenths plus 19 and 5 tenths. I want you to try this part on your own. Go ahead and pause the video right here, take the time to solve that problem, and then I'll be back with the answer. All right, are you ready for the answer? If you solved that problem correctly, you should get an answer of 54 and 8 tenths. Great job with that problem. Let's move on to the next one. Problem 3. It reads, a slice of pizza costs $1.57. How much does 27 slices cost? Do you know what operation we're going to need to use to solve this problem? If you said multiplication, you're right. I'm going to need to take $1.57 and multiply that times 27. But before I do, I'm going to estimate first. I know that $1.57, or 1 57/100, when rounded to the nearest whole number, is going to give me 2. Next, I'm going to multiply 2 times 27 to come up with an estimate. 27 times 2. Well, we know that 2 times 7 ones equals 14 ones. And we can use a number bond to rename 14 ones. I can rename 14 ones as 4 ones and 1 10. After I do that, I know that my 4 ones is going to stay down at the bottom, and my 1 10 is going to go up here above the 2. Let me show you. Here you'll see the final answer. 4 ones stayed down here, and the 1 10 came up in my tens column above the 2. Now I can say that 2 times 2 tens equals 4 tens, plus my 1 10 is 5 tens. So I have my estimate, 5 tens and 4 ones, which is read as 54. So I'm estimating that this pizza is going to cost about $54. Let's find the actual answer now. So if I want to find the actual answer, I need to take $1.57 and multiply that times 27. But to do that, I want to turn this decimal number into a whole number. So to do that, I'm going to multiply it times 100. That will turn 1 57/100 into 157 times 27. Now, I'm just working with a regular multiplication problem. So, I'm going to multiply. I know that 7 times 7 ones equals 49 ones. And we can rename 49 ones as 9 ones and 4 tens. That's why we carry the 4. We need to move those 4 tens over into the tens column. Next, I'm going to multiply 7 times 5 tens. 7 times 5 tens is 35 tens, plus the 4 tens is 39 tens. I can rename 39 tens as 9 tens, so the 9 I can put in the tens column, and 3 hundredths. That's why I move the 3 up above the 1 in the hundredths column. Now, I'm going to multiply 7 times 100. 7 times 100 is 700, plus the 300 that's already there, which is 10 hundredths. So I'm going to add in a 10. Next, we need to multiply by the 2. But before we do that, I need to make sure I put a placeholder in the 1 because I know that the value of the 2 is 20. Now, I want you to finish solving this multiplication problem, and I'll be right back with the answer. Here's the next part of your answer. How did you do? You should have 3,140, but you know next that you would need to add. If I added those together, I would get 4,239. But I know that's not the answer to my problem because in the beginning, I multiplied by 100. So what is the opposite of multiplication? If you said division, you're right. So I now need to take 4,239 and divide it by 100. Those decimals that I moved over in the beginning, I need to move back over the opposite way in order to get my final answer to this problem, which is $42.39. Not too far from my estimate. My estimate was a little more, but that's to be expected because I rounded up to begin with for this problem. You all are doing great. Let's move on to our final problem. Our final problem reads, a clipboard costs $2.23. It costs 58 cents more than a notebook. Lisa bought one clipboard and one notebook. She paid with a $10 bill. How much change does Lisa get? Use a tape diagram to show your thinking. So first, on your piece of paper, go ahead and make a C. Next to that C, make a bar and label it for $2.23, the price of a clipboard. From there, make an N, and then you're going to make another bar. Except that bar is going to be a little bit shorter because we know that a notebook is 58 cents less than a clipboard. And the problem, it states that the notebook costs 58 cents more, or the clipboard, costs 58 cents more than a notebook. So if I take the price of a notebook and I add a certain amount onto it, I'll have the price of a clipboard. That amount that I could add onto it is 58 cents. So we're looking to find the price of the notebook now. How am I going to find the amount of that bar there? If you said subtraction, you're right. I need to subtract $2.23 from 58 cents in order to find the price of the notebook. Now, I know I can't take 800ths away from 300ths. So looking at my 2/10, I'm going to rename that as 1/10 and 10/100, which I'm going to add to my 300ths to make 13/100. 13/100 minus 800 is 500. Now, I can't take 5/10 away from 1/10. So looking at my 2, I'm going to rename that as 1 whole, or 1, and 10/10, which I can add to my 1/10 to make 11/10. 11/10 minus 5/10 is 6/10. From there, I can bring my decimal down, and 1 minus 0 is 1. And we're talking about money here, so I know that this is $1.65. And that is the price of the notebook. So that brings us to our practice set. Your practice set today. I've pulled 4 problems for each of you to practice with. One of them, you'll notice, is the problem we just started together. A clipboard costs $2.23. It costs 58 cents more than a notebook. And we just determined together that a notebook costs $1.65. So, knowing that, if Lisa bought one clipboard and one notebook, and she paid with a $10 bill, Can you figure out how much change Lisa would get back? And can you do so showing your thinking using a tape diagram? I know you can. Practice with these 4 problems today. And after you practice, I've created a special challenge for each of you watching. I want you to create your own decimal word problem using the numbers 2 and 200ths and 4 and 5/10. So incorporate these 2 numbers into your problem. And if you want to include other numbers in your problem too, that's fine. But I want to see your problem. Scan this QR code so that you're able to post and write in your problem on our Padlet wall. I can't wait to read and solve all of your problems. I'll see you guys next time. Bye.